A very warm welcome to Oxpoon, the Technic magazine with Wolfgang Rudolph. Hello and a very warm welcome. Today I will try a theme which is so trivial that we don't really have to talk about it, to make it complicated. But you know what I'm like. A power adapter. When I talk about a power adapter, most of the people say, yes, okay, I know what that is. For my mobile phone, for my tablet, and so forth. Is that a power adapter? Or is it a power supply unit? You have to differentiate. A device is a device. And a device, a radio device, has a power adapter. Because it gets the mains voltage out of the voltage supply, but a power adapter doesn't have a radio. It is maybe splitting hairs, but a device is an independent device, and that what we have for our mobile phone or similar, looks like, similar to this, really big and really chunky. They have become fine and smaller, meanwhile they are so small. I want to show inside of one. I have dismantled one here and we can see inside. That is one for 5 volt voltage. There is the connection for the USB power supply. Here is the inductance and a few condensers and other things. It also has a power cut. I could show it, but I don't know if it's necessary. You can see here a break in the conductor tracks. Here we have the prime side and the pre-prime side. Here I have a total contact protection. I can touch everything here. I don't have contact with the mains voltage, where here is different. Just as a little input. But for what we need, this is clear. But there are lots of other areas outside our mobile phone which we need mains supply. Usually we take a battery, 3 cell for this, or we make a battery ourselves out of many monocells or prime cells. That is a nice thing, but the battery voltage sinks further down so long as the battery is getting empty. It is not a battery pack, and we are getting the energy through the chemical compound. It will always get smaller, but we are in a laboratory and want to measure something and want a constant voltage supply. When we repair a device or something, then we need a power supply what gets out of the 230, 240 mains and changes it into what we need, and that it holds it stable. Even if the load changes, you might remember in old houses when the cables were so thick and you turned the heat on and the lights went a bit darker. It is clear so high the load, so less the voltage drop, and at the end so small is the voltage. It should, though, not happen in a laboratory. If I have a load, wobble my voltage has to stay stable, but how do we do that? Have a look at this. I have brought really old things with me. A transformer, it has many secondary windings for more out voltages. That does things by cogwheels, you could maybe imagine. They have a small cogwheel and a larger one. And if you turn a smaller one, the large one turns much slower. The small needs more turns until the larger one has turned. That is the gear ratio. That is what a transformer does from 230 volt, changes it over different coils, over primary and secondary to the secondary side to a lower voltage. To what I need or what the transformer maker has built in. It is really heavy. I don't know how much, and if you look here, you can see the iron core. This is needed, so to say, that the magnetic field is trapped, so that it doesn't go away like a radio wave. so that you have it to go from the primary side to the secondary side to get as much loss as possible. There is laminated, that means there are lots of thin plates to keep the eddy current small as possible. That's how it starts. A long time ago, if you can remember, they had ringing transformers. That's what they were called, because they were in a counting case or next to a counting case. And there came 220 or 230 volt in, and out came 3, 5 or 8 volts or something like that. And there were the doorbells in a row, so that if someone pushed the doorbell, it was modern in those days, somewhere in the house the bell rang. They weren't compliant or safe or so, and then they were built so, and you could clamp it onto a rail. With these, we did lots and played lots with them. That was only alternating voltage. We need, though, for most of our devices, DC voltage, and we have to convert from alternating current to direct current. Saline rectifier like this here, what is written on it? B30 C1000 per 30 volt 1 amp. Later you had this design. Then we had proper cast parts. This could do a little more. What stands there, it could 30 volt, and what stands there 3700 and not chilled 2200. Even smaller ones there are. There are even smaller ones. So then we have from this alternating voltage made DC voltage. That was a great step, but this DC voltage, that was pulsing alternating voltage. We made only alternating voltage plus and minus folded up and had the double frequency DC voltage. And when you simply connect it to a loudspeaker, it had horribly buzzed. Imagine you want to repair an amplifier with a power supply unit and you hear only a buzzing DC voltage sound. You can't see if it works good or not at all. Then you need something like this. That are Elcos, Electro Compensators. They are for a low voltage with a massive capacity, gives also in other forms, smaller like this for example. Imagine if you have somewhere a water pump, a hand pump, and when you pump a gush of water comes out. That in a bucket which has a hole in the bottom. So, and then you pump and down in the bucket, the water runs out smoothly. That is what the Elco does. It loads and gives the load away. Through this, the DC voltage is flattened. It doesn't go wavy like this, but smaller wobbly things. Doesn't do enough really. You should be able to rule that out. You have one from the wobbling voltage, a control voltage, over a voltage splitter, goes over 2 or 3 transistors, which rule out these things. There we are on a good path. It looks like this. I have here a transistor, an old one, but a 230-55, but it has to have a cooling case, because the performance it absorbs and a higher voltage must get to it. So that it can stabilize a lower one. The performance has to go somewhere. It is given away, so to say, as heat and into the cooling case. It sounds all complicated. Over decades it has been improved. Used to have things like this from me, what I brought with me. We built things ourselves. You can see here a cast transformer, and here you can see a rectifier, and here the Elco, and here are 2 fast voltage regulators. Those are integrated circuits where a few transistors and iodine are in. That makes sure that the exit possibly even is. Also by changing of the load. So who had that? He was a king. Later you could buy them also settable for different voltages. That was then nearly the end of the tale. You had to though still dissipate heat, because if you want to stabilize and you take less power out of the power supply, then you have to take the other power from the transformer. It doesn't just say I'll send less now. That you have to lose. That what I use less for my device, measure, repair or whatever, I have to, so to say, consume an artificial load, so that it stays equal. That works today in higher function, where we have years and years tinkered or searched for with more or less results, with buzzing and resound, and waves on the DC voltage that is relatively perfect. For this there are many devices, as well for the hobby, as well for the professional area. There are lots more where the exactness must be, very high voltage consistency must have, and so forth. I have had a look at a few devices. Hello together. I have here from PC the LPS 1305 and had a look at it. That is a power supply which is totally suitable for the normal laboratory work, even for the upscale hobbyist who has fun with it. So now when I turn it on, it makes sense. There is the switch. You can see the blue 7-segment indicator, which are very good to read. Output voltage CV. That is here the voltage. Nothing comes yet because I have to turn it on. So now it shows 15 volt that I can regulate continuously from 0 to maximal out. 30 volt, and I can go down to a 3.4 volt. That is the area I can set here. I have also for the voltage, I want to set a fine setting wheel. It is here. It is not so coarse as the other one. I can set 0.1 volt easily. That is first the constant voltage. It stays constant by different loads. It is regulated very good here, as well as the pump part for, but we have that all in a data sheet. It is by different voltages and streams different, but that is natural. So now we come to current. I said around 30 volt, and the current 5 amps. We'll have a look at that. I'll torment it because it's not showing any power. When nothing flows, is nothing shown. I'll just short circuit it. And now we can see here 670 milliamps. And now when I turn here on the power setting, you can see it goes up to 5.1 amp. Let's turn it down and not torment it too much. The cables will probably get too hot too quick. And naturally you don't see any voltage. Why? Because the power that flows here ensures that the voltage breaks down, or the performance goes up to infinity. This thing, not because it has a transformer in it, and it doesn't make any sense. Because the devices that I work with, I want to protect. That is why I have a power limitation in it. And when the set power is achieved, then it regulates the voltage down so far that the power is not exceeded. I'll open it back up and then I have my normal voltage. So a standard device for laboratories and for the upscale hobbyist. For 30 years I would have dreamt of something like this, and with very good data. It is light, pretty light, not a heavy clump. It is a linear device. That means it is not a switching power supply, and it is usable in those areas where I have problems with high frequencies. Switching power supplies have problems often because they send out overwaves, and in radio area is not good. This is the HF area, quiet, very quiet. So the LPS 1305 from PCE, a piece what makes fun. Hello, I have here a proper heavyweight on my table from PCE, the LPS 4305. Heavyweight because it is heavy, but for all the performance is very good. When I say that is a power supply, that is not right. That's not 1, not 2, not 3, not 4, but 5 power supply units. It replaces 5 power units on my workplace. Why? Let's start with the sockets down here. When we look at them, here's channel 4, and it shows 8 until 15 volt by 1 amp. That's the first function in this device. After that, you have USB 5 volt 2 amp. I can connect it direct to USB source. After that comes channel 2, 0 to 30 volt, 0 to 5 ampere. That's the third. Then we go further here, we have channel 1, does the same as 2, 0 to 30 volt, 0 to 5 amp. Then the channel 3. That is the 5th power supply unit or power unit function, 3 to 6 volt, 6.5 even, and 3 ampere. So I can simultaneously 5 different voltages get out, and 4 you can set individually in certain areas, current and voltage. Now we can have a look at it. What I can see here in the camera is the display. It looks a bit strange, a bit blurred, that dilutes. The display is so bright that the camera is blended and makes it look blurry. I'll just ask the cameraman if we can make the picture a bit darker so that we can see. That is what the display looked like. The camera can't see the intensive blue color. It is super sharp light and recognizable. Okay, thanks. So now we are in the normal area. Let's look further. We have here, we have the possibility, the voltage to set. You can see it changes up there. And here the power reduction doesn't change because we don't take power from anywhere. That is why nothing is shown. Exactly the same we have on this side. This is shown naturally on the side. And here on this place I have the possibility to switch over. And then is nothing shown in the display. I have to first switch on the output. Now there's something in the display. Now I can hear the channel 4, I showed you that at the beginning, set separately from all others. Set my voltage onto the out from channel 4. If I switch back, I can see what I had before on channel 2. And that it is still there. Exactly the same, it works on the other side, on the other voltage out, so that wasn't everything. I have now my 5 volt and my 2 lower voltage outs and 2 higher. All independent from each other, but what do I do when I say, okay, this goes up to 30 volt normally, but really up to 32, I think, also, or 31.5. But I have devices that need 40 volt or 45 volt or 50 volt. The manufacturer have also thought about this. I have the possibility that what I do with 2 power unit normally do, that I join them together and connect in a row. That is done here internally. I have the possibility with these 2 buttons to switch over. And now in sync, both power units are changed when I turn this wheel. You can see they go up. This mode is called tracking mode because the channel 1 follows the channel 2. So and now when I connect here 1 on plus and here 2 on minus, they are internally behind each other in series. We have here over both voltages activated, serial switched and added. So now we have to look here. We have 32.52 volt, and actually I can now, using my wheel, go higher. And you can see I reach a voltage which with a normal power unit don't reach, through the adding of both. So just take these back off. Now we have the possibility, the both main power units to switch in a row to make the out voltage the double. I don't have to turn two wheels, just turn one, and through the tracking mode both power units are set to the same value. I have one more possibility, and that is I have the possibility to switch both parallel to each other. You can also do this with batteries or with normal power units or with power devices. But here it works internally. Here both main parts switch parallel. I have no out voltage from 5 amps more, but 10 ampere available. It is pretty simple when you have consumer that have a high performance and want a high voltage. And then I think with this device there are so many areas of application that you can't imagine what you can do with it. While the power units inside are set parallel, you can naturally switch over to the other two, which are independent. And you can see from these
kann man selbstverständlich auch noch umschalten auf die anderen beiden, die ja davon unabhängig sind, und kann sich auch die ansehen.
So a device, I would say, superlative, with which I can 5 different voltages and currents simultaneously use. By me on my workbench are so many devices next to each other, very old to very new. A very good solution that PCE brought with this 4305, and this is also a lineal power unit, and this is HF moderate and mute, no noise comes out of the switching power supply, and you can use this on a radio test station. I have got from PCE the PPS 3305 and put it on my table. It is a programmable power supply, a power supply network device. A network device what a bit exceptional is, but it can do much more as only voltage deliver with a constant load and voltage. For one, it has inside 3 individual independent from each other devices. And also both main parts are in the areas and programmable using a timer. You can switch the timer to and out. You can set different voltages, different values, so to say curve forms when a little angular. You can also save everything in the device. Even when switched off, is all saved and later called up. But it is all abstract. I'll show you some things. It has a nice display where you can see a very large, which is actually saved in the device. You can see in the upper 2 rows from left to right, first channel 1, it stands at 31.1 volt and has a voltage regulation of 5.2 ampere. Those are limit data. It can also 30 and a few little volts and 5.2 ampere. Channel 2 the same. Channel 3 falls a bit out of the row. It stands at 5 volt. But I can change channel 3 when I find a button. Look up here, I'll press here. Now we are at 2.5 volt, 3.3 volt, and now back to 5 volts. So that is this channel, which is here at the bottom. At these sockets I have the possibility 3 different outloads to set, and it gives me 3 ampere. Next to it you can see channel 2, and there's channel 1, and here we have the mass. That means 2 outs for the main power unit, and I can set this. Watch, I have the possibility here above to go to channel 1. Turn it on, and down here on the soft bottom switch to voltage, And here I have the possibility to change the voltage in 0.1 steps. I can though as well go to a different decimal figure, for example here, or the 1 millivolt setting, and change them. If I want to do big steps, I go here to the 1 volt settings. Exactly the same happens when I press the button current. Then I also have the possibility to change that. And when I have set it how I need it for my work or task, I can turn on my channel which I want. And that what I set up here, the should value is took over into the bottom part. Bit hard to see, it is the is value, but I have other display options. When I go to here, I get a larger, clearer display, which I can read from afar, and I get that what I just said shown large. Naturally, there would also the current that flows when it is connected to be shown too. Simultaneously, the multiplication, the load is shown in watt. This display I can also have in this form, depending how you can read it better, or what you are used to. The same I do with channel 2. By 3 you saw we can change the voltage, but that is enough normally. I have here the possibility OVP, overload, to set. The voltage when overload is. There are more possibilities. Track means what we know from other devices. Both channels are from the control switch parallel. That means I can, with one turn button on both the voltage, simultaneously increase and diminish and set the voltage. That is sensible in that case, where I go to a serial operation. We have here by serial operation, both outs are switched in a row. I can from here to here my voltage take the addition of both channels, which are always identical. That means I only need to take the display times 2 and don't have to calculate. The same goes also with parallel switching with current, that I don't have 5.2 ampere but 10.4 ampere. I can get out of it a device which is not only to operate using the rotary knob, I can also set my voltage using the keys, how you like yourself. It is some are used to using the turn wheel, others like pressing keys. I have a device at home, I use the keys for years, and it works. Over this I have the possibility to set different parameters, and it has probably come to notice that we have left an IP address. The device is delivered with software which is over the network, either network or USB, or can be operated from a PC. It can be completely operated by remote control and naturally have the remote indicator. If I had it stood somewhere in the cellar by some sort of measuring construction and I sit upstairs in my office, I can monitor it from there and operate. Then we have other things. I can go now to a timer. I can set the parameters of the device into memory places, save and later call it up. The waveform is shown here graphically. What we have to set, how should it be shown. There are attempts where voltages try to be put higher or lower. I can save it here, and as you can see, it is shown very clearly and sharp. I also have the possibility, my outs, that what I gave out of the device, to see again. It is not an oscilloscope, it doesn't do it like we usually know, but I have at least a vision device, which gives me that what unmeasured values are there graphically over the timeline, so that I can see later what has happened. I could, in this case, if one of my devices is a short circuit, I can see where, when or what has happened and can react to it. So a device which is, for one, is a total normal high-end product for laboratories, a network device which is for use with 3 outs, 1 and 3 fixed values, switchable out voltages, and 2 others up to 30 volt and 5.2 ampere go. Parallel, a serial switchable. I can operate over my normal turn knob or using the keys when I set the values, and I can lay down certain scenes, what should happen, which voltage values, which current values are to be given out, and then later call them up, and that though also graphically see. So a laboratory device which goes far, far over beyond. The network connection additionally over USB either near or over the home network brings naturally further advantages that you don't really need to sit next to it when I have my testing device in field far away and have to watch from somewhere else, monitor or control it. So the 3305 PPS, it is called from PCE. It is a powerful device which hardly a task can be done without it. 3 laboratory networks devices next to each other. Start with the smallest, a device for simple work but very stable, precise out voltage and current limitation, a very low noise proportion from the out point from PCE-LPS 1305, can go 30 volt and makes 5 ampere maximum out. Who wants it a bit larger? We have here the 5 times power supply unit, 2 main power units, 2 next to power units and 1 time mains voltage. The main power units make pro unit 30 volt, a bit more naturally as well. 5 ampere can be switched parallel and serial also up to 60 volt and up to 10 ampere you can get out of it. Also this is very stable in the out voltage and very strong. The last one is devised the new generation with a 10 keyboard. You can as usual use the turning knob, set everything current, voltage and all, voltage limitation, you get simultaneously the performance shown, and it has different display modes. This device can also parallel and serial internal be switched, that you have double voltage and double current up to 10.4 ampere. Simultaneously it can be connected to the home network or be operated from USB, so that you can operate from afar fully and reading. 3 devices which every laboratory would be glad to have, and every hobbyist is this device enough, because what in the laboratory enough is should be good enough for all hobbyists.
Discover and order the latest measuring and test equipment now on www.pce-instruments.com.